Hello all, this is my project number 9 for the VIT internship, which is image classification using deep learning. So I'll be explaining the code here. Initially, I've imported the required libraries for preprocessing, including NumPy, OSCV2, and PyPlot from Matplotlib. Then I've split the categories. I've created an array with two categories, COVID-19 negative and COVID-19 positive. This would be used for labeling as it can be seen below. Then I've created a directory path, a common directory path under the variable directory. Here I've carried out the pre-processing for the images. So here I've basically created a path for the data set using os.path.join directory and category. So for each image, the corresponding path would be formed. And here, yeah, I've got the image path thus. And here I've created label for each image, meaning depending upon their category, they are labeled as 0 and 1. Then here I've converted the images to grayscale, that is to reduce the time for training and the size and the training size. And here I've resized the image for the same purpose. So this is, and here I've printed one of the same. Uh, then I've created two arrays X and Y, and I've appended the features and the label for storing the images, and Y for storing the image label. And then I've converted it into NumPy array. Then using Pickle, I've dumped the two the two training and testing data set using pickle.dump. Now moving on to the training part, using pickle.load, I've loaded the preprocessed images and labels from my local system to these two variables x and y. This is how it had been saved, x.pkl and y.pkl. It had been saved in the same folder. I had my .ipynb file. Then here I have normalized the value for the images because the RGB value ranges from 0 to 255, so that it remains between 0 to 1. We have normalized the values. Now for the convoluted neural network, we have reshaped it using this line of code here. Now here I have imported the TensorFlow library, then Keras, and the different layers required for the training, sequential, con 2D, max pooling 2D, dense, flatten, etc. Here, the convoluted neural network for the purpose of training has been designed. So initially, these are the initial CNN layers. Here, 64 layers of 3 by 3 matrix has been created using activation redo, and a max pooling 2 and using max pooling 2D, this has been reduced to 2 by 2 matrix. The same has been repeated. Then we have flattened it, and then we have added all the hidden layers using the dense layers. Then we have used the dropout to prevent overtraining. Then here the output layer has been done, model.add dense to activation is softmax because it's either COVID-19 negative or positive, two labels. So we've used the softmax function here, and here using model selection, train test split from model selection, we have split the data into training data and testing data. uh, that is this line of code here. Then we have compiled it using the ADAM optimizer, sparse categorical cross entropy as loss, and metrics form as accuracy. Here I've initially given the epochs as 15, and using a function, if the loss value goes less than 0.01, we'll stop the training then and there itself. This is to prevent overtraining. And here all 15 epochs have been run, and we have got we have evaluated the model, and we have got an accuracy of 0.98. Then we have saved this trained model under the name COVID model. The next part is the last and most important part, which is the prediction. So here again, we've created two categories, and we have imported the necessary libraries. It had been done earlier also, and then the same code that had been written earlier of the path. And here uh, we have installed that model to the variable model. We are using the load model function, and then here I've done the prediction, and as you can see, I've to the path I've added the address of one particular image which I had chosen from the COVID-19 positive images list, and it has correctly predicted it to be COVID-19 positive. So yes, thank you.